What we'll be looking at in this video is systems of three linear equations with three variables. We're going to look at two ways to do this. We're going to look at the substitution method, which you have been using with your systems of two equations, and the Gaussian elimination. So it's really just the elimination process. So those are the two ways that we're going to look at these when we're solving for three linear equations instead of just two. So this is the first system that we are going to take a look at. You notice that we have three equations and we have three unknowns. We have the x, we have a y, and we have a z now. So like I said, we will be using the substitution method for this process. So we're going to go through steps in order to do this. The first step that we are going to take is that we are going to take our first equation, which is, I'm going to number it. That's our first equation. And we're going to solve it for z. I'm going to solve it for z because z has a coefficient of 1. I'm going to rewrite it down here. So in order to solve this for z, I need to get z by itself. So what I would do is I would move my x term and my y term over. So 2x I will move as a negative 2x, and the 7y I will move as a 7y. I will do that to both sides of the equation. So those will cancel out, and now I will have z equals to a negative 2x minus a 7y minus the 53. Then step two then, we will substitute the expression for z that we just found into our second equation. So let's look at that second equation. I'm going to label that 2, and I'm going to use a blue for that one. So I have negative 2x plus 3y plus, here is my z. But instead of the z, I'm going to replace it with what I found in my first equation when I solved for z, which was negative 2x, negative 7y, minus 53. And that will equal, on the right-hand side, my negative 13. Now, I could put this in parentheses if I want, because if I do have a negative on the outside of the parentheses, I would have to distribute it. But since it is a plus, that means we can just go ahead and combine our like terms. So what I will do next is I will look at my x terms. I have a negative 2x and a negative 2x. I will combine those for a negative 4x. Then my y terms, I have a 3y and a negative 7y. So that would give me a negative 4y. My constant of minus 53 equal to my negative 13. The next thing I'm going to do now is I'm going to go ahead and I'm going to solve this equation for y. So let's write that down here. So if I solve that for y, we need to isolate it, which means that our negative 4x and negative 53 must go. So we would add the opposite of the negative 4x for positive 4x. And the negative 53, we would add a positive 53. So we'll add those to both sides. So then that would give us, we still have the negative 4y equal now to the 4x. And now I'm going to combine the negative 13 plus the 53, and that would give me a positive 40. And then I will divide out my negative 4. This look familiar? Just like we were doing with our linear equations, right? So that would give us y equal to 4 divided by negative 4 would be negative 1, so negative 1x. And 40 divided by negative 4 would be a negative 10. So I'm going to go ahead and highlight that because we will use that again here in a minute. And now what we're going to do is we're going to kind of repeat our process, but this time we will bring in our third equation. So just like in our second step where we substituted that into the second equation, now we're going to sub it into the third equation. Okay. So we have our third equation. I will rewrite that again up here. Whoops, hold on. Okay, so I've carried over. So remember that my green one I've established to be our third equation. And remember our first equation was our purple one. And remember we had solved that for z. So remember this is from our first equation. So now what we're going to do is we're going to take that z and we're going to sub it into the third equation. So let's do that. So that gives us 6x plus 3y plus, now let's replace. So we have a negative 2x minus the 7y minus the 53. Close that off and equal to our negative 45. Let's combine our like terms. So we have 6x and negative 2x, which would give us 4x, a 3y, and a negative 7y, which would give us a negative 4y, minus the 53 equal to the, to the negative 45. So now we're going to move our 53 to the other side by adding it. So we have 4x minus 4y equal to 8. And now let's remember from our second equation, when we substituted in and solved that for y, we ended up with our y equal to our negative x minus 10. So look at what I have. Right here, I have an equation that has a variable x and the variable y. But if I look over here, you see I have a value or an expression for my y in terms of the x. So my next step is to take this expression of y and I'm going to sub it into this y here and see what we get. So then that would give us 4x minus the 4. Now replace the negative x minus 10 equal to the 8. Very important step here, you must distribute your negative 4. So we would have 4x, negative 4 times negative x would be positive 4x, negative 4 times negative 10 would be positive 40, equal to our 8. Now we've got a 4x plus a 4x, which would give us 8x, plus our 40 equal to our 8. And look what we can do now. We can actually now solve for x. So if I want to solve that for x, we'll move our 40 over to the other side as a negative. So that would give us 8x equal to negative 32, or x is equal to a negative 4. All right, so look what you just found. You just actually now found a numerical value for your x. Now from here, we kind of stop and we start working ourselves backwards. So if I know what that x value is of negative 4, I'm going to go back to my blue equation up here, remember? Whoops. And I'm going to substitute that into the negative x where I have already solved for y. So now I have y equal to negative, I replace the x with my negative 4, minus 10. So minus a negative 4 gives me a 4, and then 4 minus 10 gives me a negative 6. So look, you have found 2 of them. Now you have found what your y is. And so your final step now is to go back to your purple one. And your purple one, we will replace both of our values, our y value, and our x values. Let's go. What color have I not used? Let's go with a pink. All right, so now we have our z equals the negative 2x, but my x is a negative 4, minus my 7 times my y, which we found to be negative 6, minus our 53. So our negative 2, negative 4 is 8. The negative 7 times the negative 6 is 42, minus our 53. So we combine our 8 plus our 42. 8 plus 42 would be 50. And minus 53, we would get a value of z to be negative 3. And you have now found your z. So we would put this for our final answer over here as an ordered triple. Our x was a negative 4, our y was a negative 6, and our z was a negative 3. And check it off because you are done.